Hi guys, for today's lesson we're going to be dealing with line symmetry and rotational symmetry. So first up, what do I mean by a line of symmetry or an axis of symmetry? It's another word for it. It's a line that cuts a 2D shape into two identical shapes. This line acts as a mirror, with each side being a reflection of the other. So the idea is, people, that when you're dealing with a 2D shape, you got to think, is there any sort of line which can cut this shape perfectly into two halves? And each of these halves need to be a mirror image of the other using this line of symmetry. So the idea is we've got this line of symmetry here because it splits it into two perfect halves, and these shapes, these halves, are like a mirror image over this line. So this is definitely an axis of symmetry for this kite. Note, this kite only has one possible axis of symmetry, this one here. But some shapes have several more than just one. So for example, this rectangle, it has two axes of symmetry. A big note, however, with a rectangle is that a lot of people think that this is an axis of symmetry here, this like kind of diagonal line. But that, in fact, it's not, because this shape, even though it's the same as this shape over here, it's not. This side is not a mirror image of this side. If the mirrored image of this side right here would look something like this, and because this is the shape, not this one, therefore this is not an axis of symmetry. Next up is rotational symmetry. So rotational symmetry occurs when a shape appears identical when it is being rotated 360 about the center of a shape. So as you're rotating a shape by 360 degrees, if it ever in that rotation appears exactly the same as what it did originally, we say that's rotational symmetry. And some shapes happen that can happen frequently. Sometimes it doesn't happen much at all. Sometimes it only happens once. It'll always happen at least once, because once it does a full 360 rotation, it'll always come back to the same place and it'll look the same. So for example, if you look at this equilateral triangle, it can rotate to look like that, and then it'll rotate more to look like that, and then it'll rotate back to the start right here. So you can see like this blue side is rotating as it goes along. Because it looks the same 3 times during that 360 degree rotation, it's identical 3 times, we say that the order of rotational symmetry is equal to 3. Now, note, if a shape only has one order of rotational symmetry, i.e. only when it rotates back to the start position does it look the same, we say it has no rotational symmetry. So the idea is, if it only has one, so if it only looks the same when it does only the full 360 degree rotation, we say that it just has no rotational symmetry, instead of saying that it has one. Okay, so an example of this is this right angle triangle here. As we rotate it, it never looks the same until you've done the full 360 degree rotation. So it technically only looks the same once, and that's where the situation where if it's only once, we say that it has no rotational symmetry. If you're struggling to see how this shape is rotating to get to these sorts of shapes, like I can show you a good example of this here. So if I make that right angle triangle, so I can make one that looks like, say, this. So the way that I can do it, I can duplicate that shape and I can overlay it onto the original. So I'm putting it onto that original version. Now, at the moment, my diagram, sorry, I'll get rid of that. So if I duplicate that again and I overlay it, I can now rotate it. So it's over on the left-hand side here. If I rotate it 360 degrees, it's going all the way around. If I go nice and slowly, so we've got to think to ourselves, when does this shape go back to its original position? How many times through the 360 rotation? So if I go nice and slowly, it's not looking the same, still not looking the same. And it only looks the same when I get back to the original position of my rotation, full 360 degrees. So because it only looks the same when I get back to the start, that means it has order of rotation 1. It only looks the same once at the end. And because it's only once, that means that it has no rotational symmetry. Okay, let's do an example question. So consider a regular hexagon. First up, and a regular means that all side lengths and angles are equal. So first question is, how many axes of symmetry exist? So here's our regular hexagon. I can pretty much cut this in half like that to make, and that's going to be an axis of symmetry. You get two perfect halves like that. You can do one here. You get two perfect halves, which are mirror images of each other. Another one here, here, here. You got lots of them. So if I show you all of them, there's 6 different lines there. 1, 2, 3, 4, 5, 6. Obviously, you don't want to count that one because I already counted up here. So because there's 6 different lines that work, you've got 6 axes of symmetry as your answer. Next up, what is the order of rotational symmetry? So that means you need to be like rotating this shape around the center. So I could make this in this program again. So I'm going to make a hexagon. So there's my top. Actually, let's change it up. Here's a better way to do it. So here's my top, there's my side, there's another one. So there's my hexagon. I wanted to be rotating this, see how often it occurs, how often it goes back to the original shape. So I'll overlap it again. Notice that I'm starting on the far right, and we got to do a full 360 rotation. So how many times does it appear exactly the same? So it appears the same once, goes back to the start, twice, 3 times, 4 times, 5 times, and finally back to the start 6 times. So in that full 360 rotation, it appears the same shape 6 times. So that means that our order of rotational symmetry is going to be 6. It appears the same, identical 6 times when rotated 360 degrees. Hope this helps with the questions. Good luck.